Y Department of Chemistry. Today we are going to see the chapter Photochemistry, and in that topic we are going to study the first point, laws of photochemistry. Okay, so in laws of photochemistry we have to study four laws. The first law is the Grothus-Draper law. So this Grothus-Draper law is also called as first law of photochemistry. Then we have to study the second law, that is Lambert's law. Next we have to study the Beer's law. And lastly, we have to see Stark-Einstein law. Okay, so as I tell earlier that the Grothus-Draper law is also known as first law of photochemistry. Then second law is Lambert's law. Then we have to see the Beer's law. And lastly, it is the Stark-Einstein law, which is also called as law of photochemical equivalence or the second law of photochemistry. So now we start with the first law, that is the Grothus-Draper law. Okay, so a statement of this law is the only those radiation which are absorbed by the system are responsible to make the changes in that system. Okay, so in photochemistry we study that the light radiations are absorbed by the system and that system shows some changes towards that light. So the statement of this Grothus-Draper law is that only those radiations which are able to absorb the light radiation, those radiations only shows or those radiations only are effective to bring out the chemical change. Secondly, study the next law of that photochemistry, which is Lambert's law. So firstly, I will write down the statement of Lambert's law. Then we will see the derivation for that Lambert's law. Okay, so statement for Lambert's law is when a beam of monochromatic radiation passes through a homogeneous absorbing medium then the rate of change of intensity with respect to thickness with thickness of the medium is directly proportional to the intensity of incident radiation. Okay, so now see, we have the statement of Lambert's law is when a beam of monochromatic radiation passes through a homogeneous absorbing medium. So what is monochromatic radiation? That monochromatic radiation means radiations associated with a single wavelength. Okay, so when these radiations passes through a homogeneous absorbing medium, homogeneous means medium that have a single phase like liquid phase or solid phase or gaseous phase. Okay, so when these monochromatic radiations passes through this homogeneous absorbing medium, here this word is important that the medium should be absorbing. When this medium is absorbing, then the rate of change of intensity of incident radiation with thickness of medium is directly proportional to the intensity of incident light. That means if in a beaker we have taken our solution, okay, and we are passing some homogeneous radiations through it like this, and we have initial intensity as I. So if we have initial intensity of radiation is I0, then when these radiations will pass through this homogeneous medium, some of the radiation will be absorbed by the system. Okay, we see in the absorption of light that when radiations passes through any system, some of that radiations will be absorbed by that system, some radiations will be reflected back, or some radiations will be transmitted as it is. Okay,